All right, here's a question for you. You've seen terephthalic acid and ethylene glycol can react in the previous slide. Now consider acetic acid and ethyl alcohol. Okay, this is acetic acid right here, little carboxylic acid group, and ethyl alcohol or ethanol is a simple alcohol with one hydroxyl group. So show how this carboxylic acid and alcohol can react to form an ester, and then could acetic acid and ethanol react to form a polyester? So you want to explain the reasoning. First of all, we want to show how the two individual monomer units can form, or the two individual molecules can form an ester. So I'll write down the acetic acid. I'm not going to put the hydrogens on because it makes it so messy. There's the acetic acid plus the ethanol. Okay. And you know that the hydrogen from the alcohol group and the OH from the carboxylic acid group are going to split off to form water, leaving this oxygen to bind directly to that carbon, giving us our ester linkage. So I'll just write that molecule over here. It's going to be C. Okay, so that's the molecule that we form, and you can see the ester linkage is right here. Now the question is, could acetic acid, this is acetic acid, and ethanol react to form a polyester? And explain. Well, once you react this acetic acid and this ethanol, then the only functional group you have is the ester. There's no leftover carboxylic acid or alcohol group to react again to keep this reaction going, as in like a chain reaction situation. So the answer there for part B is no, because there's only one functional group on each of these monomer units. In order to make it work, you'd have to have two functional groups on the monomer, not just one. Okay, so that's the difference. One of the differences between a condensation reaction and an addition reaction. The addition reaction, since you're just adding, you're just breaking that double bond, then you don't have to have functional groups, you just have to have the double bond. Whereas with this, you have to have the alcohol and carboxylic acid functional group for this particular type of polyester.